Hi, everyone. I'm Hemant, and today I'm here to share my team's journey to migrate the infrastructure nightmare of managing clusters using Terraform to the dream of managing Kubernetes clusters using Kubernetes with Cluster API or CAPI. Bit about me. I'm a DevOps engineer at Walmart, and I'm currently working to build a multi-cloud Kubernetes platform. I'm also passionate about open source and contribute to several projects like Cert Manager. So with that, let's look at the initial design of our team. The problem was that we had to deploy multiple teams to multiple clouds, Kubernetes clusters. And there were like different teams having different YAML files to generate the required HCL files or Terraform files, which then would be run through terragrunt. Terragrunt, if you're not aware about it, is basically Terraform on steroids. As we start scaling up, we started seeing cracks coming up. First, managing Helm releases and CRDs with Terraform is not intuitive. It's mostly play and apply and pray that it works. Secondly, the sheer amount of state management that we had to do was enough to make us give up on Terraform. Lastly, while Terraform was good at spinning up infrastructure, it was not good at doing Kubernetes native things like registering Argo clusters. This is where we realized we like controllers. The job of a controller is basically to sync current state to the desired state. If only we had a controller that could help us spin up clusters for us. This is where we found a Kubernetes project called CAPI. CAPI is basically a set of Kubernetes controllers that manages the lifecycle of a Kubernetes cluster. In the next 100 seconds, we're going to learn how to deploy an AWS EKS cluster using CAPI. The first component we are going to take a look at is the infrastructure provider. Infrastructure provider is responsible for deploying infrastructure required for the cluster and would correspond to where you want a Kubernetes cluster to be. In this case, we are deploying an AWS infra provider, which will then be used to spin up an EKS cluster. From here, the CAPI controller will basically deploy an individual infrastructure provider controller, which manages the individual cluster. CAPI cluster also manages the state of an entire cluster using the cluster spec, which you are going to see. So the generic cluster spec that you see here highlights two important components, which are the control plane ref and the infrastructure ref. We're going to see both of them individually and see how easy it is to deploy them. So the control plane ref here is mostly managed control plane, and the AWS is our cloud provider. And this basically deploys an EKS control plane. Up next, we have one of our cloud infrastructure spec components, which is the managed cluster. Most of the spec remains empty because it's a managed cluster. This forms, along with the machine plane that we're going to see, the basis of the non-control plane nodes in EKS. So the control planes, machine pool and the AWS managed machine pool you see here forms the non-EKS control plane nodes. In our case, the AWS managed machine pool basically deploys an auto-scaling group. So why would we do this? One, it's gitops friendly, which means that all of our cluster-related stuff can be stored in a single repo, and that, as a platform team, forms a single source of truth for us. The second reason is that this enables multi-cloud support. We deploy infrastructure providers to support multiple clouds. Gone are the days of needing to recode Terraform modules and building specific cloud provider-specific pipelines to run those modules. Of course, CAPI also has downsides, just like everything else. The first major downside is that it's community-driven, which means that features are hard to come by, and infrastructure providers adopt it later. The second reason is continuous reconciliation can be tricky. On our team, it has led to scenarios where the entire cluster is torn down because there was a bug in the spec. We handle this by following better SDLC processes. At the end of the day, CAPI is just a cluster, is a controller just to deploy a cluster, which means that it doesn't eliminate the need for creation of cloud resources. You might have to deploy controllers like ACK to deploy supporting resources. So when should you use CAPI? If you're a team that loves using Kubernetes and has a fleet of clusters and want to manage it irrespective of the cloud, then I highly suggest your team to try controlling clusters using CAPI. With that, thank you for coming to the DevOps days, and enjoy the last few days of summer. Thank you.